We're going to be studying lines and angles. Our first thing up is to think of some new terminology that we may not have thought about before. The first one will be there exists. Use the symbol. It's a capital E that's turned backwards. And pretty much universally in mathematics, that's recognized as to mean there exists. And it's presumed that it means there exists at least one, that one of them does exist, but there could be more, as opposed to the backwards E with an exclamation point, which means there exists one and only one of whatever we're talking about. We could also say there exists uniquely one, there exists exactly one. So here's terminology. You're welcome to use it. Sometimes you can use it instead of things like given. It depends on the circumstances. A couple of definitions. Parallel lines. Parallel lines are lines that do not intersect and are coplanar. So here, if we have two lines, they're in the same plane, they're lying on this white surface. They do not intersect, they're in the same plane, they are parallel. Okay, well, what if I did like that? Oh, they're going to intersect somewhere, intersect out there somewhere, right? It's going to go out there. So they will intersect when they're extended. Skew lines. Skew lines are in three dimensions, not merely in two on a plane. They do not intersect and they are not coplanar. So if we have red pencil line, blue pencil line. Oh, it looks like the intercept, but no. When I rotate it for you, you can see they're not actually intersecting. See, I'll rotate them. They come around, and you can tell they're not intersecting. They are skewed, is what we call them. Okay. Parallel. How do we label parallel on a piece of paper? We have some conventions about that. Oops, wrong one. So here we have two lines that are parallel. We mark that these two black lines are parallel by having one arrow in each. Similar to the hash marks and the angle measures that we've already learned, the same number means that those are the ones that are parallel. Two marks here that are arrows pointing the same direction means that these two blue are parallel, and the black ones mean that the two black ones are parallel. I have an issue here. If I have a line and a point not on the line, I'd like to be able to see if I can draw a line through that point that's parallel to that line. Let's see. Oh, well, that's not it. It's not either one. Okay, that's through the point, but it's not parallel. There it is. Through the point and parallel. Okay, well, can I draw another one? I'm going to try and draw another one. Oh, well, that's through the point, but it's not parallel. Oh, that's parallel, but it's not through the point. Through the point, but not parallel. Up. I would have to put it right there. And when I put it right there, it's the same line. It's not a different line. So what have I just demonstrated? That through one point not on a line, you can do one and only one. There exists one and only one line through the point and parallel to the line. Here's the postulate that states that. Similarly, let's talk about a point not on the line and a line. Now I want to draw one that's perpendicular. I wonder if I could do that. Let's see. Okay, that looks perpendicular. We'll say that it is. Okay, now can I draw another perpendicular one through the point? Okay, well, that's perpendicular, but it's not through the point, so that doesn't work. That's through the point, but it's not perpendicular, so it doesn't work. So we're left with kind of the only place I can do is right there. And guess what? That's not a different line. It is the same line. So we say there exists one and only one line perpendicular to a given line and passing through a given point. the perpendicular postulate. How do we name lines? Here's a line, and that line we're going to name L. Mathematicians being occasionally not particularly, inventive with their names, it's probably called L because it's L line starts with L. So here I'll draw another one, and this one will be M, probably because M comes after L. Again, not remarkably innovative in terminology. Let's say they're parallel. Okay, we'll get a mark like that. That means that L and M are lines that are parallel. Okay, what if I do another one? This one's going to be N. Again, not overly creative in terminology. Let's say that line N is parallel to line M, marked with the two marks. So how would I write that? Line M is parallel to line N. Up here, line L is parallel to line M. So then we have the, let's see, what about line L and N? Well, if those are all parallel, and that's parallel, well, yep, it is. It's kind of obvious, but we have a postulate to tell us anyway. Excuse me, it's a property. If two lines are parallel to a third line, they are parallel to each other. Now, it's technically not exactly transitive, but you're allowed to use this for this class as an abbreviation. Remember, when you're doing these things, it's a good idea to say the whole thing over, maybe even to write it to help you remember. Two lines that are parallel to a third line are parallel to each other. It's kind of a transitive line. So their conclusion here is that line L is parallel to line N. In your cipher there, please draw this drawing in your cipher. You can press pause or whatever. Label the numbers the same on the angles so that you can, when I'm talking about it, you'll have the same numbers on your paper. Take maybe a third of a page, maybe to a fourth of a page, so you'll have a little room to work in your cipher. Write it down like this. Get you a piece of patty paper if you're home. Wax paper will work, or just some thin paper that you can see through if you don't actually have patty paper. Put it at your angle 1, wherever your angle 1 is, and trace a fairly long enough line so that you can tell your angle. We'll do that to get started on it, and then we're going to talk about first some of the terminology that has to do with lines and angles. So here's the same lines. Two ways we'll talk about it. One way is relative to the two lines that might be parallel. These happen to be parallel. They're not necessarily parallel. So two lines that might be parallel. Between them, inside, we're going to call interior. So one way we will describe these lines, the angles on these lines, are that they are interior angles between the two parallel lines. Now, it may be obvious, but the ones that are not interior are exterior, whether above or below. Please make sure you mark in your cipher what we're doing. So, interior, exterior has to do with between or not between the two parallel lines. This line is one line that's crossing the others. It's called a transversal. Okay, a transversal transverses. That means it goes across. I could say, I'm going to transverse the street and go to Subway and get me a cookie. Woo! Okay, transverse the street. The Transcontinental Railroad transversed the country. It went across the country. This transversal goes across the two lines. Some of the things that we'll have here, when we're talking about relative to the transversal, we'll talk about whether they're on the same side or not on the same side. So angles like down here on the left would be on the same side. Angles down here on the left would be on the same side, but if there's one here and one here, they're on different sides of the transversal. So different sides we're going to call alternating, and we'll only take notice of those in certain circumstances, which I'm about to talk about. So alternating. And then on the same side, we'll talk about ones that are consecutive or ones that are corresponding. Okay, let's talk about consecutive first. Consecutive's kind of easy. So if we have a line, that's our transversal. Remember, these are relative to the transversal, not so much to the, we call these based on the transversal. So if they're all on the same side, it's like they're all lined up on the same side. Same side, consecutive. These pins are consecutive along the side. If they were making angles, they would be consecutive angles. This one, this one, this one. Think consecutive. 1, 2, 3, 4. They're all consecutive, right? But what if I said 1, 2, 6, 7, 9? Those are not consecutive. They got to be the ones that are right next to each other, like the yellow and the pink and the blue and the yellow, orange, but not the orange and the yellow. They're not consecutive because there's this blue one and this pink one in the middle. So we're not going to call them consecutive. Okay, what about alternating? Okay, still relative to the transversal now. So we'll have a guest lecturer here, Froggy, to help us with this. Hi, Froggy. Okay, so let's see what Froggy does. Froggy's going to illustrate for us how we do alternate angles relative to a transversal. So Froggy will start here and plop his froggy foot down on the left side. He's going to like hop around. Frogs like to hop along, so he's going to hop along. Okay, so there's foot, and then there's foot. See Froggy foot? We're looking at the front feet right now. Foot. Yay! The next one, and that's on the right side. He walks again. Yay! On the left side. On the right side. On the left side. On the right side. On the left side. Yay! See Froggy, he is alternating. Right foot, left foot. Right foot, left foot. Right foot, left foot. Right foot, left foot. Yay! I have alternated. Okay. So the alternating angles then will be the angles like you're hopscotching across this line. Like that. Okay. So we have one left, and it's the corresponding angles. I'll go back to the ones with the numbers now to do that. Corresponding is going to be which ones are at the same relative location, and a lot of people have a lot of trouble with this one. So let me recommend that you get yourself a card and cut out a square hole, because that way you can remove or ignore all the extraneous data. So put it right over the intersection that you want to look at, and think about it as being like in a picture frame. And in this picture frame, you can kind of see that 1 is upper right, 7 is upper left, lower right, left, lower right's the 5. So what you do is you start at your starting place at the X, at the intersection of the transversal and one of the purportedly parallel lines. Excuse me. And you say, okay, well, for example, 1 is in the upper right-hand corner of my frame. Okay? Well, I'm going to slide to where I'm going down here to see what corresponds. You slide on the transversal only. Slide down to transversal. Slide, 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 slide. Up, there it goes. Okay. The 1 was in the upper right. The 2 is in the upper right. They correspond because they're in the same relative location. 6 is lower right. Slide up to transversal. 5 is in the lower right. 5 and 6 are corresponding angles. I strongly suggest that you employ this frame idea. It just takes a while for most students to get used to the idea of ignoring everything else and focusing only on one aspect of the drawing. And these drawings will get considerably more complex as we go along. So, corresponding is going to be the same place in the frame. Alternating is going to be playing hopscotch back and forth. And consecutive is going to be just hopping on one leg down the same side. Okay? Notice that corresponding is also same side. Consecutive, you remember you can't have any in between that are the ones that you're dealing with. There might be some in between, but we'll work with how to do that. And you'll get to figure that out nicely. Okay. So here it is typed out to help you a little bit, in case that helps you a little bit. Then let's play with it some. And we'll about to be done. When you're looking at a more complex diagram like this, like I told you, using the frame helps if you want to try for corresponding. There, 1 is upper left, slide down the transversal. 5 is upper left, they're corresponding. But you notice now it's starting to get complicated. Now that it's getting complicated, you're going to have to not look at part of it. Say, for example, what you want to do is look at these two lines and this transversal. You're going to need to cover up the other part of it, if you can. Just so it doesn't confuse you which ones you're talking about. And now you can see you're talking about two lines that are purported to be parallel and a transversal. You could do it this way. Now, these are the two lines that might be parallel, and then this is the transversal. It helps to cover it up so that you can't see it. Well, let's see. If I do this, I see now that angle 6 is interior to the two maybe parallel lines. So, here's my two maybe parallel lines, and 6 is interior. Oh, it was 8 I was going to do. Let's do 8. 8 is exterior here. Didn't work out like I wanted. Look at this one. Now, 8 is exterior to the two parallel lines. If I work around and now I'm going to make this one the transversal, oh, look, it's still interior. Look at that. Isn't that cool? So you walk around and you look at it. Covering up helps a lot. Using a frame helps a lot. Remember, the frame only slides on the one you're using as the transversal, not on the others. So that's going to stop part 1 of this, and I'll come back and do the second part.